Today I am talking about S block element. Periodic table has got 4 different blocks of element. One is S block element, another P block element, another one D block element, and the last one is F block element. There are 4 blocks in periodic table. Where they are exactly in periodic table? Look at this is modern periodic table. Here we have 1A and 2A. Two groups are written here. 1A means this column of element represents group 1A. This column represents group 2A. And these two group is called S block element. The elements of group 1A and 2A are called S block element. In the same way, in right hand side, look at this here. This is group 3A. The vertical column of this 3A is boron, aluminium, gallium, etc. In the same way, 4A, 5A, 6A, 7A and 0 group element, this is P block element. Now S block is towards left hand side, there are 2 groups, and P block is towards right hand side, 6 groups. Now D block element, in the middle part of modern periodic table, this middle part is D block element. But at the bottom side, there is lanthanides and actinides. They are F block element. In this way, all the elements of this modern periodic table is divided into S block, P block, D block and F block element. Today our focus is on S block element. Let's define what is S block element. Elements in which last electron enters into S subcell of the outermost cell of their atom is called S block element. Now this is a little difficult to understand. What it means, I want to elaborate it. Look at this. Let's say this is an atom and this is the nucleus of the atom, which is central part of the atom, and there are certain orbits along which electron revolves around this nucleus. We know this, and we can name them. I mean to say they are named as K cell, L cell, M cell and N cell. There are different number of cells. There may be 7 different cells, K, L, M, N, O, P, Q. Each of the cell is divided into subcells, and these subcells are named as S subcell, which can hold 2 electrons, and P subcell that can hold 6 electrons, and D subcell which can hold 10 electrons, and F subcell that can hold 14 electrons. Each of the cell is divided into subcells. Now electrons fills up in these subcells in this order, and this order is given as Aufbau principle. And if we have to fill up the electron in subcell, then first we have to go through this 1s first cell, S subcell, and then remaining electron goes to second cell, S subcell, and remaining goes to second cell, P subcell, and remaining goes to third cell, that is M and S subcell. This way, this is the order of the filling up of electrons in the subcells. Now let's take an example. Sodium, its atomic number is 11. It means it has 11 electrons. Now how to fill up these electrons in different subcells? First we have to fill in first cell and S subcell, and the number of electron will be 2. And then we have to go to second cell, and in second cell, S subcell can hold 2 electrons. That's why we will fill 2 electrons in S subcell of second cell. After this, we have to go to second cell, P subcell, and P subcell can hold, look at this, 6 electrons. That's why 2p6. Now after this, the turn is of third cell, S subcell. Now how many electrons are filled? 6 plus 2 plus 2, 10 electrons are filled. Now only 1 electron is left. That's why this last electron goes to third cell, S subcell, and that's why we are writing 3s1. In the same way, in all the elements of group 1A and 2A, last electron enters into S subcell of their outermost cell. That's why they are called S block elements. So we define this S block element like this: elements in which last electron enters into S subcell of the outermost cell of their atom is called S block element. Okay, this much for today.